So welcome for the lesson. There are some questions I had sent to the group. I hope you are able to access them. And those are the ones that we are going to look at. Question number one. Question number one, so I will begin. One. Now, question number one, what A says, explain 4 ways in which competitive situations of games can be classified. You explain 4 ways in which competitive situations of games can be classified. So this one, you shall look for it in the notes. So make sure you get to your notes and those 4 ways of classifying games. So I got part B. Kamau and Joroge are 2 cousins specializing in working business along River Road. Kamau specializes in second-hand shirts, while Joroge specializes in cheap electronic goods. However, sales have been decreasing per trade due to the harsh economic condition in Kenya, and partly due to the restrictions by the city council. Each of the cousins is considering expanding to include in their lines of business items on which their rivals now have a monopoly. Each knows that the other is considering this expansion, and this influences each of their decisions. Kamau figures out that if he does not expand his business and his cousin does, it will hurt his trade by 500 profit per day. If neither of them expands inventory to include the extra product, Kamau thinks it will boost his net profit by shillings 500 per day due to his superior location. If he expands and his cousin does also, he believes the combination of location and expanded inventory will increase his profits by 1,000 per day. However, if he alone expands and his cousin does not, this will result in no net increase in business. Required, prepare a game matrix and show that a pure strategy does not exist. So in handling this question in game theory, I told you you need to identify who are the participants. You need to identify who are the participants. You need to identify who are the participants of the game and the strategies they are using. So the first participant is called Kamau here. And Kamau is considering expansion or no expansion, or no expansion. That is what is considered. Then we have his cousin on this side, who is also considering the same thing, expansion and no expansion. No expansion, and this is a guy called Joroge. So this is what we call the payoff matrix. Draw like that. The payoff matrix. So in recording the values, we know when we are dealing with these payoffs, that again to this player who is on this side is a positive, and the loss to him is a negative. Again to this person is a negative, and the loss is positive. So let's argue from the perspective of Kamau. We are told Kamau figures that if he does not expand his business and his cousin does, it will hurt his trade by 500. So he does not expand, but his cousin expands. So they meet here. Then Kamau will lose 500. So this is minus 500 there. Minus 500. If neither of them expands to include the extra product, Kamau thinks it will boost his net profit by 500 per day due to his superior location. So Kamau is thinking that if neither of them expands, neither, so no expansion, it will boost his net profit. So gain to Kamau is positive 500. It's a positive 500. If he expands and his cousin does also, he believes that the combination of the location and the expanded inventory will increase his profits by 1,000 per day. So if both of them expands, Kamau will gain 1,000. Kamau will gain 1,000. Then, however, if he alone expands and his cousin does not, this will result in no net increase. So if no net increase, that means it is zero. It is zero. Now from there we know that we begin by extracting the minimum, or sorry, the maximum here. The maximum here is 1,000, and the maximum here is 500. It's 500. Then this guy uses what we call minimax strategy. Minimax strategy. So minimax, that means we will go for the smaller, that is 500. Then on this side, we have to extract the minimum. We have to extract the minimum. So the minimum here it is 0, and this is minus 500. That is 500. So huyu anatumia the strategy we call max min strategy. Max min strategy. So he will go for the maximum of those minimums. That one. That way. So with that, no saddle point exists. No saddle point exists. No saddle point exists. Hence, it is a mixed strategy game. Mixed strategy game. It's a mixed strategy game. Is a mixed strategy game because you can see what we have selected here, they are not similar. So we saw using algebraic methods. We solve using algebraic methods. We solve using algebraic methods. And I'm just going to put those values here. Or maybe we put it separately. So we say solving using algebraic methods solving using algebraic methods. We will come here. Solving using algebraic method. For the interest of the space, I will call this one expansion here, E, and this one I call it N. This is because of Kamau. For the interest of space, I will use those initials. Then here, this is E and N, and this is for Joroge. And this N has nothing to do with Joroge. It is just the first letter for the no expansion. So the payoffs are 1,000. This is minus 500. This is 0. And this is 500. That is 500. I told you there are three steps that we take. The first step, we call it subtract. We call it subtract. So in subtracting, you take the higher, you subtract the smaller. So here it will be 1,000 minus 500, and the answer will be 1,500. And then for the second column, it will be 500 minus 0, and the answer will be 500. That is the first step. The second step, I told you, is called interchange. You interchange those values. So 500 comes here, and 1,500 gets there. 1,500 gets there. The third step is the probability or the proportion of time, and the probability will be 500 out of 2,000. These two, when you add, you get 2,000. Then 1,500 out of 2,000. That is as far as the columns are concerned. As far as the columns are concerned. We go to the rows and do the same thing. We subtract. We subtract. So subtracting, it will be 1,000 minus 0, which is equal to 1,000. Then 500 minus 500 is equal to 1,000. It's equals to 1,000. Then you interchange. Interchange. To interchange, I have 1,000 here and 1,000 there. You interchange. And then I have the probability here. So this will be 1,000 out of 2,000. This will also be 1,000 out of 2,000. We interchange that. We interchange that way. So when you interchange that way, the next thing now is to get value of that variable. Value of that variable. And I told you what to do. Unachukua this pair of 1,000. You multiply by the column probability, which is 500 out of 2,000, multiplied by the row probability, this one, which is 1,000 out of 2,000. Plus, you go to the next one, this one, 0, multiplied by the column probability, which is 1,500 out of 2,000, multiplied by the row probability, which is 1,000 out of 2,000, plus you come to this one, which is minus 500, multiplied by the column probability, which is 500 out of 2,000. You multiply by the row probability, which is 1,000 out of 2,000. Out of 2,000 plus here mwisho 500 multiplied by the column probability 1,500 out of 2,000 multiplied by the row probability 1,000, you divide by 2,000. So work out that and send me the answer. Work out that and send me the answer. Send me the answer. Yes, Alice, how are you? But good afternoon. Send me the answer. Thank you. What is the answer for that? Waiting. The answer is 250. The answer is 250. And confirm that. The interpretation or the meaning of that, now that it is positive, is that Kamau will gain shillings 250, while Joroge will lose shillings 250. That is the meaning of that positive value. That is the meaning of that positive value. Can we proceed? Okay, here's Vati. Okay, so we then proceed. Look at question number 2. Question number 2. So question number 2. Question number 2 is saying you define the following terms: dominance, saddle point, mixed strategy, and value of the game. All those things are very clear in the notes that I gave you, so ensure you check. Part B. Consider the two-person zero-sum game between players A and B given by the following payoff table. Now, using the max-min and min-max values, is it possible to determine the values of the game? Give reasons. So, is it possible to determine the values of the game? So, once again, we come here and have something like this. Value of the game. So we have player A here who has strategy 1 and 2. We have player B who has strategy 1, 2, 3, and 4. That is participant B. And the values are 2, 4, 2, 3, 3, 2, minus 1 and 6. minus 1 and 6. So as you know, when we are solving games, when you have the payoff matrix, the first thing is to extract the max mean, rather the maximum here. So the maximum here is 4, this is 3, this is 3, and this is 6. Those are the maximums. And when we are using the min-max strategy, when we are using the min-max, you go for the minimum of those. So the minimum are 2, 3, 3. So you can pick either. But before we pick, let's go to this other side. We get the minimum. The minimum is minus 1 here and 2. And huyu anatumianga max min. That means you will go for the maximum of the maximums, which happens to be this one. That is the one that he will prefer. So A, rather B, can be guided by this one. Now that A has chosen this one, if B picks these 3, they will meet here, and this being a positive value, it is a loss to B. So B will lose 2. But if he goes for this one, they will meet here. And being a positive value, B will lose 3. So it is better for B to lose 2 than 3. So based on that, he will prefer to go for this one. He will prefer to go for that one. Now, when he prefers that way, you can see the selections are not similar. So that means the game has no saddle point. The game has no saddle point. That game has no saddle point. When the game has no saddle point, if you remember the flow chart, the next thing you ask yourself, is it a 2 by 2? Like what you have done with question 1. If the answer is yes, you solve using algebra. But now for this one, the answer is no. So if it is no, you apply what? Dominance. What is called dominance rules. And dominance is aimed at reducing the game to a 2 by 2. Now this one, you can see it is already 4 in terms of the columns. So if you wanted to reduce it, you must do away with 2 columns. And remember, I told you, you dominate in an alternating manner. You dominate in an alternating manner, meaning when you dominate a column, you go to a row. Once you are through with the row, you go to a column, but not columns zimefuatana ama rows zimefuatana. So the examiner was asking, is it possible to determine the value? So the answer is no. So it is not possible since it has no saddle point. I think I've already answered that. The answer is no, since it has no saddle point. Now use graphical method to determine the optimal strategy. You use the graphical method to determine the strategy. So I told you what to do. So down there you say solving using graphical methods. Solving this using graphical methods. You check the highest values. The highest value is 6 kati ya zote, and the lowest value is -1. So you do a scale. You do a scale. One, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. So I told you, we draw 2 lines like this. How wide apart from each other they are, that one you decide. To not be too close, not too wide. And then, maybe for the purposes of labeling our axis, this one we can baptize it to A1 and this one A2. Even these ones we could also baptize them that way, so that they don't confuse us. So that this one will be our A1 and this is our A2. Our A1 and A2. And I told you the title of that graph. The title of that graph is where is the strategy of the person who has 2 strategies. This one. So we will call it max mean. So this one will be titled max mean. We are calling it max mean because these 2 have come from this participant here who is using the max mean strategy. So hapa this is 6, 5, 4, 3, 2, 1, 0. So that means I needed another one here. That is -1. The same case here. This is 6. This is 5. This is 4. This is 3. This is 2. This is 1, 0, and -1. At -1. When you do that, you start connecting these points. 2, 4. So 2 and 4. Upper. You connect them with a big straight line. 2, 4. That way. Ingine is 2, 3. So 2, 3. That way. Huyu mwingine ni 3, 2. 3, 2. The next one is -1, 6. -1 and 6 here. -1 and 6. When you draw, you now argue this way. This person is trying to maximize the minimums. So someone who is maximizing the minimums is already in the region of minimums. And minimums go. So this fellow is down here trying to come up. Akona huku chini anajaribu kusonga juu. And this is what we call feasible region. So the guy akona huku chini trying to go up so that he can maximize the minimums. So he will go up to the farthest corner, which is this one. So this is where now you have value of the game, V, which is equal to, so let me read from my own. Now that this is 2, this must be 2.5. So according to my table, the value is 2.5. The value is 2.5. Then down there you say the game reduces as follows. The game reduces as follows. So you come and identify these 2 points, those 2 lines that make the corner. So we will be 2, now we will begin at 2, 3. So 2, 3 and 3, 2. So itakuwa namna hii. So for player A, we have A1 here and A2. For player B, amebakishiwa B2 and B3. Hizo ndio zimetengeneza these 2 lines. So 2, 3 hapa. Na huyo mwingine ni 3, 2. So that is how the game reduces. That is how the game reduces. So you solve this now using algebra, just like we have done with the other one. So you subtract. So this will be 3 minus 2 equals 1. And this will also be 3 minus 2 equals 1. Then you interchange. So this one there and one there. And then probability. Probability will be 1 out of 2. 1 out of 2. You come and do the same thing here, where you say subtract 3 minus 2, that is 1. 3 minus 2 again, that is 1. you interchange here. You interchange where you have 1 and 1. Then you have the probability here, which is a half and a half. And therefore, finally, you come down here and get 5. Here, kwanza utasema ni 2 times a half times 1 and a half plus 3 times a half times a half plus 3 times a half times a half plus 2 times a half times a half. So work out that and send me the answer quickly. Send me the answer. Send me the answer. Yes, what I can say 2.5. So that 2.5, because it is a positive value, it's a positive value, it is a gain to A and allows to Alice, are you okay? Good. So we are through with that. Let us now go to question 3. Question 3, we are told Huduma Hospital operates 3 different types of wards, namely intensive care unit, high dependency unit, and general ward. The average monthly cost of maintaining a patient in each of the wards are 400,000, 200,000, and 100,000 for the ICU, high dependency, and general ward, respectively. Past information on patients indicates that, so we are given all that. And down there now, we are told to get the matrix of transition probabilities. Matrix of transition probabilities. So that question is from the area we call map of analysis. And in dealing with that, again, you know so well the matrix of transition probabilities. matrix of transition probabilities. Nachorwa namna hii. We call it transition matrix. On this side, we say from transition matrix from we have three states. We have the ICU, we have the high dependency, and we have the general wards. Then here we have ICU, the HDU, and the GW. This is 2. That is the design of a transition matrix. And we said losses are recorded in a row this way, and gains are recorded in a column. So we start reading as we record. Information 1 says 50% of the patients in the ICU at the beginning of the month will remain at the end in ICU at the end of the month, and 50 will be transferred to the high dependency. So from ICU to ICU, 0.5. That is a retention. From ICU to high dependency, 0.5. That is a loss. And because in a row, we must always add 1. We must always add 1. Then this must be 0. That must be 0. 10% of the patients in high dependency at the beginning of the month will be transferred to ICU by the end of the month, while 50 will remain in high dependency and 40 will be transferred to the general ward. So from the high dependency to ICU, we are going to send 10%, so that is 0.1. And then high dependency, we retain 50. Then to the general ward, we will send 0.4. 0.4. 85% of the patients in the general ward at the beginning will remain. So general ward, 0.85. Then, whereas 10% and 5% will be transferred to high dependency and ICU respectively. So high dependency will get 0.1 and ICU will get 0.05. So that is the transition matrix. Transition matrix. Part 2. The expected proportion of patients that will be in ICU, high dependency and general ward by the end of December 2013. So that one will be argued like this. Will be argued like this. You take December 2013. Start of December 2013. Start of December 2013. You multiply by the transition matrix. You multiply by transition matrix. You multiply by transition matrix. What you shall get, is end of December 2013. End of December 2013. You take the start of December that way. So this one now, takuwa namna hii. We will argue like this. This is the ICU here, high dependency here, and the general ward. Towards the end there, we are told past hospital records indicate that the hospital admits on average 5,000 patients monthly. At the beginning of December, the hospital had 10%, 25, and 65. So this is 0.1, this is 0.25, and this is 0.65. You multiply by the transition matrix, whereby here we have ICU, high dependency, and the general wards. ICU, high dependency, and the general ward. And this one, as earlier determined, is 0.5, 0.1, 0.05, 0.5, 0.5, 0.1, 0, 0.4, and 0.85 should be equal to ICU here, high dependency, and the general ward. And the general wards. So you multiply, and you remember we normally take these ones, we multiply by these ones as we have. So itakuwa hivi 0.1 times 0.5 plus 0.25 times 0.1 plus 0.65 times 0.05. is 0.1075. 0.1 times 0.5 plus 0.25 times 0.5 plus 0.65 times 0.1 is 0.24. And because they must add to 1, you can add these two, you subtract them from 1. You get 0.6525. 6525. Are we okay at that point? If we are okay, say my yes. Good. So then we proceed. So those are the shares at that 7. Now you are told to get the steady state. You get the steady state. So getting the steady state, you will argue like this. Let market shares or the shares in the long run, to be, you rate the shares, the market shares of the proportions in the long run to be, for ICU to be X, for high dependency to be Y, and for the general ward to be Z. ICUX, high dependency, and general ward. Down there is saying where X plus Y plus Z is equal to 1. Where X plus Y plus Z is equal to 1. Then I told you, you reduce by 1. You say Z is equal to 1 minus X minus Y. 1 minus X minus Y. So ukisema hivyo akibia hapa utuambie then we have X here, we have Y, then 1 minus X minus Y. So instead of Z, you bring that. You bring 1 minus X minus Y. Then you bring the transition matrix. You bring the transition matrix. You bring the transition matrix, which is 0.5, 0.1, and 0.05, and 0.5, 0.5 and 0.1, then 0, 0.4, and 0.85. To be equal to x, y, 1 minus x minus 1. That is how naipanga in the long run. If it's a 3 by 3, but kama ingekuwa 2 ukitumia xy, so sasa you start multiplying. So on multiplying, this becomes 0.5x plus 0.1y plus 0.05 minus 0.05x minus 0.05y. It is equal to x. When you multiply these ones and these ones. So putting like them together, we will have 0.5x to be joined by minus 0.05x to be joined by minus 1x. How what the x plus 0.1y minus 0.05y should be equal to minus 0.05. Then you open the brackets. 0.5 minus 0.05 minus 1. You get minus 0.55x plus 0.05y is equal to minus 0.05. And this one you call it equation number 1. You call it equation number 1. Do the same thing with the second right, so that you have 0.5x plus 0.5y plus 0.1 minus 0.1x minus 0.1y. It should be equal to y. Again, put right terms together. 0.5x minus 0.1x plus 0.5y minus 0.1y minus y should be equal to minus 0.1. So sasa hii nayo itakuwa namna gani? Itakuwa 0.5 and That would be 0.4x. Then 0.5 minus 0.1 minus 1 minus 0.6y equals minus 0.1. And this one, you call it equation 2. So this one you can solve using spontaneous method or matrix, but maybe I could remind you how to solve using matrices. So I'll say using matrix algebra to solve 1 and 2. We are using matrix algebra to solve 1 and 2. Then nafahamu vizuri, we will have minus 0.55 here at 0.40. Then 0.05 and minus 0.6. Those are the coefficients of the two equations. Being multiplied by x, y to be equal to minus 0.05 and minus 0.1. So from there, you will proceed here and create a matrix x, y here being equal to this one, unakimbia the other side. So I have minus 0.55 and 0.4, then 0.05 and minus 0.60. Na hii inaingia hapa ikiwa inverse. It comes in as an inverse to multiply minus 0.05 and minus 0.10. Then proceeding na hii maneno yenye unajua kabisa is that we will need to get the determinant as minus 0.55 times minus 0.6. That's the major diagonal. You minus 0.4 multiplied by 0.05 that would be the determinant. This determinant comes in to multiply comes in to multiply the new matrix. And the new matrix, we change position for the major diagonal. So that is minus 0.6 and minus 0.55. Then you change the signs of the minor diagonal, minus 0.4 and minus 0.5. Times minus 0.05 and minus 0.1. So sasa hii safari inaendelea namna hii. I start by getting the determinants. So I get 0.31. This one, you know how to multiply matrices. So tutasema minus 0.6 times minus 0.05 plus minus 0.05 times minus 0.1 equals 0.035. And I think we can combine the two. Combine. So that one I divide by 0.31. And if I use 4 decimals, I will record 0.1129. Niende kwa hilo mwingine, minus 0.4 times minus 0.05 plus minus 0.55 times minus 0.1, 0.075. You divide by 0.31 again to 4 decimals. Thus, X is 0.1129, Y is 0.2419, and Z will be 1 minus 0.1129 minus 0.2419. Hence, Hence, if you come here, examiner alikuwa anauliza tafutia kitu inaitwa steady state monthly cost. Steady state monthly cost. Steady state monthly cost. Kianza na ICU. The whole hospital, we are told it has 5,000 patients. So of these 5,000 patients, this proportion or this percent will be in ICU, 0.1129. And every person who is in ICU for the month is costing us 400,000. Then high dependency, the same thing. The hospital has 5,000. Of that, 0.2419 will be the high dependency, each costing 200,000 to maintain. Each costing. Huyo mwingine anaitwa general ward, 5,000 with 0.6452 times 100,000. Then finally we will be able to tell these guys what are the cost implications. This is 322, 600,000. $241, 900,000. $225, 800. So this is 790, 300. ICU 225. Okay, good. Can see we are in agreement, party. We are okay after that point to type yes so that we can move now to the next agenda. We move to the next. Okay. Question number 4. So question number 4. A Malaysia economy has 3 industries: motor vehicle, electricity, and steel. And these industries are interdependent such that the output of one industry is the input of another. The following table shows the input ratios of each industry. So we have that. And the relative matrix. So you are told to define the term input ratio. That one I would suggest you check in your notes. The meaning of an input ratio, AIJ, the quantity required from sector I for sector J to make 1 unit. You'll be able to see those kind of things. Determine the primary inputs required by each industry. If the final demand is, we are given all that. If the final demand is that. So for us to get the primary inputs, we will require to know the output. We will require to know the outputs. So hapa tutasema hivi: x is equal to I minus a inverse multiplied by 1. That will be the beginning. Look at your notes on input output, you'll find that from me. So we are already told about this. We are already told about this matrix. We are already told about this matrix. So this matrix of the universe, we are already given that it is 3.08, 2.64, and 3.96, 1.98, 3.41, 3.19, 2.15, 2.70, and 4.46 times the final demand matrix is 216 here, 240, and 360. That is our matrix 1. So when you multiply, the answers will be 3.08 times 216 plus 1.98 times 240 plus 2.15 times 360. It is 1914.48. 0.48. Then 2.64 times 216 3.41 times 240 plus 2.7 times 360 is 2360.64. 3.96 times 216 3.19 times 240 plus 4.46 times 360 is that 226.56. This is now for mid-sectors. This is vehicles. This is electricity. And this is steel. Are we getting the same answers? Okay. I want us now, as we answer that question of the primary inputs, or maybe I could have given it separately. We'll have the sector here. We have the sector here and the primary inputs. So starting with the vehicles, I told you what you do. You get 1 minus the items in the column of the technological coefficients matrix of that sector. So 0.17 minus 0.25 minus 0.5. That represents the primary input. You multiply by the output here of 1914.48. Then huyo mwingine anaitwa electricity. Electricity, which you say 1 minus 0.25. 0.25 minus 0.33 multiplied by 2360.64. And then for steel, it will be 1 minus 0.25 minus 0.33 minus 0.33. You multiply by 326.56. So this one I'm getting 290.3904. One 53.1584. This is 401.3088. That is how you get the primary. So are we okay? Aris? Good. I have 20 more minutes or 18 minutes. And I don't think it will be enough to handle question 5, even 6. So let us handle question 8. Let us handle question 8 for the few minutes that are remaining. And make sure when you revise your notes on the input output, you look at the technological coefficient matrix table, the table that you drew. You remind yourself about that. So let us go to question number 8. Question 8, we are told Medicino Limited is a pharmaceutical company that manufactures 2 types of cough syrups, Rara and Saram. The total cost and total revenue producing the cough syrups are as given. So we have that. And you are told to get the maximum profit. So as you know, profit is revenue minus cost. Profit is revenue minus cost. So our revenue is minus 38,400 S. You minus 36L squared. You add 438 S squared. You add 2 million. Then you minus the cost. The cost I have 1 million here minus 486 S squared minus 324 SL minus 27 L squared minus 27 L squared. Open the brackets to get minus 38 400S minus 36 L squared plus 438 S squared plus 2 million minus 1 million plus 486 S squared plus 324 SL plus 27 L squared. So you put like terms together. Write terms together. And I told you when you have this kind of a function, you go mark in who you have picked so that you don't forget. So this minus 38,400 itajiunga na hakuna mwenzake, hakuna S, so hiyo itabaki minus 38,400S. Then this L square minus 36 itajiunga na huyu 27. So utasema minus 36 plus 27 wajue minus 9L square. This S square itajiunga na hii. So utasema 438 plus 486. So it is positive 924. Positive 924 S squared. This one to join hard so that we are left with plus 1 million. And this one, so it back plus 324 SM. So this one is a case of partial differentials. So you will tell us that if we need maximum profit, for maximum profit, the differential of R with respect to X should be the same as the differential of phi with respect to L, which should be equal to 0. When you differentiate that function partially, you should get zeros. So now, when I start here, the differential of phi with respect to X, to S, hapa itabaki minus 38,400. This one becomes 0 haina S. This one becomes plus 924 times 2 is 1848 S. Huyu hana S, so it becomes 0. So huyu atabaki plus 324L. And say is equal to 0, which you call equation 1. The differential of pi with respect to L. With respect to L. S becomes 0 in L. S becomes minus 18L. U 0 and L, 0 and L plus 324S. Is equal to 0. And this one you call it equation number 2. So I can choose to remove L. So removing L from 1 and 2. The whole of this I will multiply by 18, and the whole of this I will multiply by 324. Multiply by 324. So we begin. We say 38,400 times 18 is minus 691,200 plus 1848 times 18 is that 3264 S plus 324 times 18, 58, that 2L is equals to 0. Alafu 324 times 324. This will be 104,976S minus 18 times 324. 58, that's 2L. Now these ones I will need to add. I will need to add so that my L disappears. So inabaki minus 691,200 plus that 3,264 plus 104, 976 is 138,240S equal to 0. Meaning that if I need S, it will be 691,200. You divide by 138,240. Let me get that answer from you. Get that answer now. Send me that answer. Waiting for the answer. Good. It is 5 units. Then, using equation 2, we will say minus 18L plus 324 times 5 is 0. So that will mean that L should be what? So times 324 divided by 18. L should be 90 units. L should be 90 units. Thus, maximum profit would be equal to, sasa hizo values unaziweka kwa hii function ya profit hii. So it will be minus 38,400 times S, which is 5, minus 9 times 90 squared, plus 924 times 5 squared, plus 1 million, plus 324 times 5 times 90. When you put all those values there, you then say minus 38,400 times 5, minus 9 times 90 squared, plus 924 times 5 squared, plus 1 million, plus 324 times 5 times 90. I'm getting 904,000. You gotten the same? Good. So we then call it a day at that junction and hope to pick up from there. So make sure you get time to revise on the area that you have touched today. Make sure you get time and revise. It's important. Then we pick up from there in the next lesson. Thank you so much.